Cool, I'm starting now. So, hi guys, I'm Ashika, and today I'm going to be taking the in-course session for Docker and a little bit of CI/CD. So, do you guys have like a basic idea of what Docker is? Like, you can say anything you want. Anybody?
So it kind of packages your entire backend, right? And you'll be able to use it in different operating systems. And you wouldn't have to worry about the dependencies.
Cool. Yeah, that can be said, but uh, what I would like to define Docker as would be a virtualization tool. So like you have virtual boxes. Docker is kind of sort of like that, but a bit better, and we'll see why. So to understand Docker better, let's look at how basically operating systems work. So the thing about operating systems is that we have three layers in all operating systems. One is the application layer, second is the OS kernel, and the last one is the hardware layer. So what happens is that this application layer is going to be built on your OS kernel, and the kernel is going to act as a middleman between your hardware and your applications. So the OS kernel is going to interact with your monitor, your keyboard, and everything, and all the applications that are going to be built are going to be on top of this OS kernel. So like every OS has a different kernel. So Windows has a different kernel, and Linux has a different kernel. So the key difference between normal like Docker and virtual boxes, virtual machines is that Docker virtualizes only the application layer, but VMs, what they do is that they also virtualize the application plus the OS kernel. So that is a key difference. So you can understand from this that because we don't have a kernel in Docker, it's going to be lighter, faster, and you can do basically much more with it. So that is a key difference. Are we clear on that?
Yeah.
Yes.
Yeah, let's go.
Cool. So to understand Docker better, like you guys might have heard about these terms, containers, images, right? So what is a container in Docker? So think of a container as a box in which you're going to put all your dependencies and configurations of your application. Because it is in a container, it's going to be so easy for you to move it around, right? And it's going to speed up like this exact point will make sure that your development and deployment processes are going to be really fast. So that is what a container is. If you want, you guys can visit this website. It has a lot of uh, basically images and stuff. So right now we just discussed what containers are, but I'll get to what images are in just a second. You can see like there are a lot of images on Docker Hub. Like this is like the official repository where all images are going to be present. So back to our presentation. Why do we need Docker? So basically what used to happen was before we had a development team and we had a DevOps team. So the development team used to, once they were finished with developing their application, they used to have an instance of the database and their jar file, or jar file is basically a package.json but for Java. Like it has all the dependencies and configs. And they used to provide the operations team with a textual guide on how to set up the application on servers. So you see, because this process is so divided, it you like in the middle there used to be so many problems that used to happen because like the versions wouldn't match. Sometimes the application was built on top of an operating system which wasn't suitable for the DevOps team. So it basically caused a lot of problems and it was very painful. You can see the DevOps person is crying here. So that is when containers came. And what did containers do? Containers, basically, they package the entire application with all the dependencies and configs inside one container, which could be moved around from the DevOps team and the operations team. So what they just needed to do was start this container on their server and uh, Like it did not matter what machine your container was running on, it would work perfectly fine. So that is why we use containers. Now, previously I mentioned images and containers. So uh, the key difference between an image and a container is that an image is the actual package or the artifact, but the container is the running environment of that image. So, say if I were to pull this image from Docker Hub and I were to start it on my local machine, that running environment of that image would become a container. Do you guys get that?
Yes.
Cool. So, basically, that is a brief intro on Docker. Do you guys have any questions uh, on what we've learned so far? If not, we can start with the
Could you
command. Yeah.
explain the image and container again?
Sure. So, what an image is, it is the actual package uh, which is there, like the artifact. But when you start that image, it becomes a container. Like a container is basically an image in a running environment. So a container is layers and layers of image. Like there could be like a base image, which would be like a Linux distribution, and there could be lots of applications stacked on top of that base image. Say you have a Postgres instance and you have a Redis instance. So like these images together would be stacked together, and then when you start all these images, it would become a container. So the only difference between an image and a container is the container is the running environment of an image. That's all.
Oh, okay, got it.
Yeah, it's just like a play of semantics. You don't really like there's not a very big difference, but it's a slight difference and it's just semantics. Now we will move on to Docker commands. Let me open my terminal. Do you guys have Docker installed?
No.
Okay, no problem. You guys just see what I'm doing. So I have Docker installed. Let me see what Docker version do I have. I have Docker installed. So to to basically run to check if your Docker installation is correct, you run this command. This is the simplest Docker command you can ever get. It is docker run hello world. So the hello world image would be retrieved from Docker Hub and it would run on your system. So you can say it's where did it go? Yeah, hello from Docker and a few things. So this message shows that your installation is appears to be working correctly. Now let's read this. What does Docker do when I run this command? Docker run hello world. The Docker client contacts the Docker daemon, which is basically the Docker hub where everything is uh, like everything is stored, and Docker daemon pulls hello world image from Docker hub, contains creates a new container from that image which runs on the executable that produces the output which you are currently reading, and Docker daemon stream that output on my terminal. That is all. It's just like a continuous series of processes, but like it's good to know what is happening when you run this command, so that's why we did it. But say if I went over here and I wanted the Redis image, the official Redis image, you would see the command that they are telling us to copy paste on our terminal is docker pull Redis. So I ran docker run hello world. So basically, what docker run does is that if you don't have that image already present on your local system, it will pull that from the Docker hub, and then it will run the container. That is all. So if I were to pull Redis into my system, it would just pull it from Docker Hub, and then I would have to run it. So like it's now two steps. But with Docker Run, I can do it in just one step. That's all. Let's wait for this to get pulled into my system. Also, few more commands. If you want to see how many images that you have on your system, you can just use this command docker images. You'll see you have these many images. We had hello world. We just ran the hello world container. Now Docker PS is basically all the containers that are currently running in my system. Right now I don't have any containers running, but we will start a container very soon. So I've pulled Redis, which is the latest version. You see that a lot of layers are getting pulled. So it's like a lot of pulls complete you will see over here. So that is what I meant when I previously mentioned that a container is basically layers of images. There's going to be so many images that you're going to be pulling from Docker up. That is all. Let's start this container, Docker run Redis. So Redis has started, ready to accept connections. The thing about Redis is that it has like an already given port, which is 6379. We can change it, that's fine, but like it's the port that Redis uh, like it's the
Uh,
port where yeah.
Ashika, could you zoom in on the terminal?
I'm sorry. Let me make it full screen. Yeah. Is it better now?
Yeah.
Cool. Hmm. So this port is basically something that Redis recommends us to use, but we can always change it. So right now we've started our container. Now let us use the command over here, and we can see, hey, our container is running. It's up and running on this port on our local system. We have a container ID, the image, command. So like to when you run this command, Docker run Redis, like Docker has like this shell script which will start the container. You have the status, ports, and names. So you can change this name to whatever you want. Docker assigns it to a random name. Say I exit this container. What if I wanted to wait, I'll clear my screen. What if I wanted to run this container and also check out how many containers are running at the same time in one terminal? What would I need to do? Because right now I have to switch to another terminal and see how many containers are in. See, the container has stopped. So for that we can do run a container in a detached mode. So we can use dash d, which will run it in detached mode, and a container is running in the background. Basically, that is what all that this is. To do docker ps, you will see, yep, it's running. Yay. So let me stop this container with the container ID, and it will get stopped. Now, what if I wanted to rename this container to something that I want? Say, I want this to be first-redis, and then so basically this is how you can name your container to whatever you want, right? Oh, I didn't run it in detached mode, so you'll have to go over here and see. So you see we have a container first-redis running. Now, if I were to close this, the container would stop. Let me run this in detached mode though. Dash T. It's already used. You have to rename the container. Cool. I'll rename it. Docker rm first redis, and then I will run. Cool, it's running. So a cool thing about Docker is that you can. Yep, it's running. Cool thing about Docker is that you can basically run different versions of the same application or service. So say right now I'm running the latest Redis version, but what if I wanted to run a previous version? So what I would do is I'll go back to Docker Hub and I will see which version do I want to pull. Say I wanted to pull this version, 5.0.13. this image I will pull onto my local system. So docker pull redis. Yes. Cool. So now we'll wait for Redis to pull, Docker to pull this image. You see, because we're pulling up an existing version and we've already pulled the latest version of Redis before, you can see like some layers already exist in my system, but the new ones can be pulled. So it takes lesser time. I'll start this container, say docker run dash d dash name second Redis. Be sure to specify the version and this will run. Now let's see docker ps. So here you can see I have two containers running for Redis and both of them listen on same ports. So I have a question for you guys. Do you think this is a problem? Like two containers listening on the same ports?
Yeah, right. Because how will we able to distinguish between both the
Yeah, exactly. So what would you suggest to overcome this problem?
changing the port name?
Port name?
Yeah.
Okay. Yeah. Cool. Like that's correct. That's what we would do. So first, let me stop both these containers. First Redis and second Redis, so that I don't have any clashes with the container names. Here. Now, how would I change the port? Let's try with first Redis. So this is how you bind a port in Docker. This port 6000 is basically the port on your local machine, and over here this is the one for the container. So I was saying that this is the port for your local machine, that is your local host, and this port is the port that your container is going to listen to. That is the only thing that you need to keep in mind while binding ports in Docker. And we will run a Redis container. It's already used. Fine. I'll stop it. Docker rm first Redis. Now let's run it. Cool. It's running. I do docker ps. I will see that my localhost port 6000 has been binded to the container port 6379. Cool. Also, one more command you can do docker ps -a to see all containers. Uh, like docker ps only shows the containers that are currently running, and docker ps shows all the containers that have ever ran. So that is that. Now let us do the same with the second Redis container, that is the older Redis version. Docker run dash d in detached mode dash name. Wait, I have to remove it first because it's already there. Second Redis here. Docker run dash d dash name. Second Redis port. How about I bind it to the same port as the previous one? Let's see if some error will happen, or will it will it be super enough to run on the same port? Hmm. See, port is already allocated, so it won't be able to run this container on the same port. Let's change it to 01 for RM second Redis. And now should be fine now. Cool. It runs Docker PS, and you see our containers are running perfectly fine. If you want to stop them, just use docker stop. first-redis and second-redis. And one more command which you should use with your discretion is docker system prune. We'll see what it does. This will remove all stop containers, all networks that are not used by at least one container, all dangling images, and all dangling build caches. So this command you can use if you want to remove everything, all stop containers, and it will basically make like a lot of space will be left after. Oh, because I've already stopped all containers, so it's fine. But if I had like dangling images or whatever, then I would be claiming a lot of space. So yeah, that is all. Do you have any? Do you guys have any questions about these commands?
No.
All right. Are you guys able to follow? Should I go a bit slow or something? Okay, I'll take that as a no. So this project, you see we have a Docker file and everything. This project is basically a normal, simple create React app uh, project. Like there's nothing new in this. So how do we start this project? You would just run npm start, right? Wait, what is my script? Npm run dev on your local machine, and then it would open up on your local host 3000. Let's see how this project looks. So you can see it's a basic create React template, nothing new. We ran it on our local machine. We can see what it looks like. So let's try to run it on Docker. First, let's have a look at our Docker file. So think of think of Docker as somebody who doesn't know what to do at all, and you have to give it every single instruction. Like it doesn't even know how to start a computer. So for my Docker file, I will first have to tell it, okay, hey, you take this uh, Alpine Linux distribution, right? And why Alpine? Because it's a really light base image, like it's like almost like 5 MB or something. So it's really light and it's ideal for using in Docker files. Then you would tell your Docker file, hey, set a working directory. Like this is where I want my project to be built and ran. If you have any environment variables, you tell it, okay, like this is my environment variable, my port number is 3000. And then you start with your dependencies. You start installing your dependencies. You install npm, and you copy your package JSON, package log JSON, you do npmi, copy the entire project, and then you build your project. And when everything is done, you just use npm start. The npm start in my project is basically a serve script. A serve script is basically it's going to serve all the static files in my project, which are there in the build folder. It's nothing very complicated. It's very simple. Let's try to build a Docker image using this. So to build a Docker image, we will use the command docker build dot, that is build everything, which is in this Docker file, with a tag demo project. Cool. So now it will send the build context to Docker daemon, and our project will build. It might take some time depending on what kind of project you have. Mine is relatively smaller because it's a template project, so it won't take that much time also. let's wait. So till now, what we have learned on the terminal was just working with already existing images. Right now, what we're doing is that we are creating our own image from our project. So all the steps that have been laid out in a Docker file are going to take place using the build command. Like every single step is going to be run. Right now, it's installing npm version 7. Do you guys have any questions about this?
So if you want to view the project, would we use like the normal localhost 3000 whatever, and then when we're building it, only then we will be using Docker, right? Or
Um, yeah, I'll answer that question in a little while. Like you'll understand what happens very soon. Let's just wait for it till our image is building. How about I introduce you guys to a bit of CI/CD? This
yes,
can this can this is not exactly proper CI/CD, but it's just an action that I wrote. What is this action going to do? Is that it's going to publish this image that we're building over here to my repository. So let me go to my repository ashika/demo project. Hmm. So this is like a basic repository. What my action does, it you see in the packages section, it just pushes this image over there, and you can pull this image into your system and run it on your local system. That is all the action does. So I'll start. So uh, to write any action, there are a few things that you need. Number one is that you need a .github folder with a subfolder called workflows, and inside the workflows folder, you need to have a YAML file with your action. So my action name is publish package.yaml. So thing about YAML files is that you need to be really careful with how you format it. So I'd suggest you install a YAML formatter. It will make your life less painful. We'll start with how this action works. So it's basically self-explanatory. You have action name is publish. This is something which you can define on your own. Like it's not predefined or anything. If I wanted, I can just say publish yada yada, whatever. No problem with that. Then over here is where the magic starts. So uh, every it's a GitHub action, right? The keyword being action. So when you push something on a repo, it's an action. When you create a pull request, it's an action. So think of it like that only. So when you push on the master branch, I want these jobs to happen. That is all that's happening over here. So if I wanted like a pull request action, I would just change this push to pull request. That's all. And then you define your jobs. You can change this to like any branch you want. Like if I had like a dev branch or a feed readme branch, anything you can want, you can change it to that. Then you have the jobs, and you can define first job, which runs on Ubuntu latest, like you're defining the machine. Then you have the steps which this job is going to use. Over here, like these are some actions that have been defined by GitHub. Like we don't need to get into those details. Like these are predefined actions which I'm using. Uh, Basically, what we're doing is that we are going to log in into the GitHub container registry, which is basically like Docker Hub. Like Docker Hub, people can push whatever images they want. Right. So you log into the GitHub container registry with your credentials, and then you build your demo project image and you push it. That's all that is happening here. So as you can see, this our build is successful. Now let us run our project. An error will happen, and I want you guys to guess why. See, it can't connect to localhost.
Do we have to go to a different port?
Yeah, it does have to do something with port. Any guesses? It's fine.
Do we have to have Docker running in the background? There was some
It is
Docker port 6000.
it is running in the background, but like you're pretty close to the answer. What is happening is that I need to bind my local host port. So I need to expose it. So I would do this. Right now, my containers 3000 port uh, is open for connections, but my local host, it doesn't know what to do. That is why this problem is happening. So if I do this, let us see what happens. Cool. Enchante. It works. So right now what you see is not me doing npm run dev. This is a Dockerized application which is running, and like it's running inside a container. Cool. Does that make sense to you guys?
Yeah.
Yeah. So basically that is what's happening. Now uh, let's over here we have build project demo project image action. I can also make it a two-step thing. So say I have push demo project image, and then I have run command with the pipe control shift I. Yep. So right now in the job section I have one job, two job, and like a third job now because I've like basically how do I say converted the first like over here we had like two commands together, but now I've divided it into one more sub command. Let us push whatever change we have made till now. Mm, new job action. See. Let's see. See, because I made a push on my master branch directly, we are going to start with our action, and in a few seconds, when everything is built and pushed, we would have our package available over here, and you would be able to see a tick over here. And if it's a cross, then sad life, you will have to debug it. It will take some time. Anyway, like that's the gist. Do you guys have any questions?
No.
I had a question with respect to the preview and build. Like, would
Mm-hmm.
we be able to preview the projects or like in Dockers, or would we have to build it every time?
Uh, could you repeat your question? Like I didn't get it.
Like, for example, we have localhost 3000 running, right? And we
Yeah.
build the we built the Docker application, and does it mean we need to build it again whenever we change something in the?
Yeah, because every change means that something will be different in your image, right?
Hmm.
So that is why the build will keep happening with every little minute change. Even if I place like a random console log anywhere in my project, which doesn't directly affect my affect the image, it will still rebuild everything. Anyway, that is basically. Let's just wait for this to finish. When we see a tick, we can have like a fun exercise. Uh, what you guys can do is that since we have an already like our image is already here, right? It's been pushed. How about you guys pull this image and run it on your local systems, right? See, yeah, our action passed, all checks, so everything works. Now, you guys, whoever has Docker installed can pull this image. Let's do that. Docker pull. Just like GitHub container registry, there are a lot of things where you can push your images and containers too. So, like for AWS, there's ECR, and there's Docker Hub, like a lot more things that I like. It doesn't come to mind right now, but yeah, let's wait. Also, I think like this is the end of our session. So if you guys have any like even like stupid questions, something you did not understand in the middle, you can ask me right now. It's fine. Like it took me some time to like understand Docker properly. You can just ask away. I think it's done almost. Now we will run. Finish. Oh, mistake हो गया. My life. Run. Let's see what happens. The same problem will happen here also, I think.
पोर्ट
Because
बाइंड नहीं किया
port bind नहीं किया. ये अब port bind करना पड़ेगा. Let me find the ports. Please shut down. 3000 to HP 3000 to 3000. Let's run it again. It should work. Local host. Oh, it works. Nice. So, with this, we come to the end of our session. Uh, that's it.